We are moving on to object-oriented programming in Java. And in this class, we're going to define what object-oriented programming entails, Java as an object-oriented programming language, what are objects and classes. We'll also look at something called UML, which is Unified Modeling Language, class and object diagrams, how to create objects, constructors, getters and setters, and we'll look at an example. These are the learning resources for this class. And object-oriented programming is an aspect of programming that is not functional, but it's a programming paradigm that characterizes softwares or programs or apps that you write as objects instead of functions or logic. So it bases the programming on real-world examples to make programming easy. Like I said, the main objective of object-oriented programming is to implement real-world entities, and it has some benefits. It's easier and faster to execute. It provides a clear structure for programs. It is easy to modify, maintain, debug, and is reusable. And it brings about lesser code and development time because you can reuse it in another application, you can reuse it in another project, you can reuse it in the same project. Java is partly an object-oriented language and uses different OOP concepts such as classes, objects, methods, constructor, interface, inheritance, polymorphism, data encapsulation, abstraction, pluggability, and modularity. So we'll be looking into classes, objects, methods, constructors, interface, inheritance, polymorphism, data encapsulation, abstraction in the course of this course throughout this course, but today we'll just be looking at classes, methods, objects, constructors, and we'll look at these in the coming weeks. So what is an object? First of all, classes and objects are building blocks for object-oriented programming in Java. So these are the things that are required for OOP to work in Java. Objects are anything around you, literally your bag, your laptop, anything you can see around you, your chair, your table, if you have a bicycle, different things that you know that has a state and behavior. State is attributes data that you know about the object. So if you have a bicycle, in your bicycle you probably have a gear, you have a pedal, you have a tire, you have the flashlights. Even you're an object. You have your name, your age, your eye color, your hair texture, different things around you. And you have a behavior. You can walk, you can type something on your phone, you can ride a bike, you can move a table. And in this, we have some examples of objects that has state and behavior. So my table has states like height. I know my table's height, weight, length, type, color. The behavior, I can move my table, I can change position, I can pair it with a chair. For a bicycle, I have the pedal, gear, brakes, tires, wheels, and I can change my gear, I can apply brakes, I can fix tires. For my light switch, I've got two main states, on and off. So I can either turn off or turn on. And it might be simple as this or more complicated with different states and different behaviors. Even a dog, there's the name of a dog, there's the breed, there's the color, there's the eye color. Your dog barks, wags, is still fetched, and sleeps. So these are behaviors of objects. Anything around you that has a state and behavior is known as an object. And classes are basically how you format your objects. They are blueprints for objects. This is what you use to define your objects and know what your object will look like. So it defines the state and behavior of your object, and it makes it easy to represent scenarios in the real world. And a class has variables and methods that we just looked into. So your variables define the state of your class. It holds the data for your class, and your method defines the behavior. So this is what you want your objects to do. And you can create multiple objects from a class. A class can be defined once, and from that class you can create thousands of objects that do different things. So this is the main benefit of class. You can create a class once, and the class can give birth to different objects, basically. We have something called a class diagram, and this helps us to outline what variables and methods will be used for our class and how classes are associated with each other. And you can draw your class diagram based on software specifications or scenarios, meetings with the BAs, with the PO, the product owner, project manager rather. So from all this, you can draw your class diagrams out of that. It's basically kind of like an entirely different course on its own, but it's useful when you want to create classes and objects. Unified modeling language is the language used to document business systems from an object-oriented point of view. So you basically document what you want the project that you're working on, what you want your product to do from an objective point of view. So you basically document them based on objects. And two of the diagrams that are associated with UML are class diagrams and object diagrams. Like I said, class diagram is used to represent classes, which contains attributes and methods and their association. And object diagrams are used to represent an object and its values that are the attributes in a class. So these two pictures, this is a class diagram and this is an object diagram. The class diagram here is, the class name is user, and it takes in it has three variables of name, gender, and age. So the name is a string, the gender is a string, and the age is an integer. And for my class user, I want it to have three methods. So I want it to have a method where I can order food, and I don't want it to return anything. It doesn't also take in a parameter. I also want it to have a method that asks if my user has siblings. I want it to return true or false, doesn't take in a parameter. And I also want another method where the user can update their profile. And I also don't want it to return anything. So an object diagram is used to represent an object with its values. So the object diagram will look like this. The user is user 1. The name of that user is John. The gender is male, and the age is 25. This is how a class diagram and an object diagram will look like. It's usually more complicated than this, but this is a simple diagram that represents one class. Yeah, like I said. And from this class, different users can be created from this class. So I can have user 1, user 2, user 100. Different kinds of users can be created just from this one class. So different kind of objects can be created from this class. And this is an example. So from this one class, I defined or I created three objects. User 1, user 2, and user 3. I created an object named John, and the gender is male, the age is 25. And I created another user named Betty, and the gender is female, age is 30. And another user named Stacy, with the gender female and the age 30. This is an easier illustration without all the name and the variables and the methods. So user is the class, and it has three objects: John, Betty, Stacy. Basically like something you give birth to. So from this class, we created three objects based on these specifications. So these objects will also have name, gender, and age, and we'll also have these three methods in it. So for us to declare this class, you've probably done different kinds of class declaration without even realizing it, because when you create a class, that's the class declared. So you need a public class user, and the class diagram is useful because it basically tells you what to put in your class. So I have my name, which is a string, and yeah, I'll just declare it public string name, public string gender, public integer age, and then I'll define my methods, which is public void order foot, public boolean has siblings. I actually changed this to put in one parameter, and public void update profile. In my IntelliJ, I have a class called user. I'm actually going to extend it because people were asking for that. Created a class called user. If you want to create a class, you just right click on your source and you create new, and you click on Java class and you create a class. So I'm going to declare for public string name. So I'm declaring three variables: public string gender, public integer age. And I'm going to declare three methods: public void order foot, public void public boolean as siblings with an integer number of siblings. This is the access type, the return type, the method name, and the number of parameters, which is one parameter rather. And I have another one called public void updates. Just gonna double check to see if that's what I put there. Update profile. Okay. So this is my class created. I'm going to put in some things here, just some system.out.println, system.out.println, which is, I would say something like name wants to order a 3-course meal. And in my update profile, I would do something like, if you want to update, let's say, your age, you would, let's do the siblings first. If number of siblings is greater than 0, So this is the method I'm working on right now, and it's called as siblings. So it needs to check if my user has siblings or not. So if the number of siblings is greater than 0, then print out system.out.println name has plus number of siblings plus siblings. So this will basically print out if the name is John, John has, and the number of siblings is 2, John has 2 siblings, and it returns true. So return true. Else return false. And say John has no siblings, or name has no siblings, whatever name you put there. We also need to do an else if the number is equal to 1, so it just says sibling instead of siblings. Else if number of siblings is equal to 1, so the method doesn't, we need to return true. So this is the method. If it takes in a parameter called number of siblings, if the number of siblings is greater than 0, it prints out the name and the number of siblings that user has. And if it's equal to 1, it prints out that it has 1 sibling. And if it's not equal to either of them, then it says the number of siblings, the user has 0 siblings. So I'm going to define that method. Okay, so this is, and we need to do update profile. To update the profile, I'm just going to print out system.out.println sorry. And then age. So this is a class that we've created, and before we go into object creation, we have to understand how it works. So we have created this class that it's a user, the class name is user. It takes in 3 variables, which is name, gender. It defines 3 variables, name, gender, and age, and has 3 methods: order, food, ask siblings, and update profile. And for an object to be created, 2 things need to take place. The object needs to be first declared in your main class, and then memory needs to be allocated. So I'll first declare the object. So to declare the object, you go to your main class, and we're going to actually make it a clean slate. To declare your object, you need your class name. Your class name is user, and I'll enlarge this. User. Then the next word is any word you want to name your object as. So I'm naming my object as user1. This is our first step. So we first declared the object, which is the class name and the variable you want to call your object as. My variable right now is user1. This is what I want to call my object. So the next step is to use a keyword called new. So this helps to create your object, and it also allocates memory to that object in Java. So we're going to do user1 equal new user. Basically, it just says user1 equals to new user, which is a new object. And like I said, the new keyword is responsible for memory allocation in Java. So I'm going to explain how memory allocation works. When you first declare an object, so when you say user1, when you declare an object, in this case, we're declaring a user1, that is the variable we're using to reference our object. The variable is declared in memory temporarily, and let's say this is our memory on this white screen here, and this is our user1. This is our object defined in memory. When we use the new keyword, then the memory is then an actual memory is allocated to the object and its variables. So this is the variable that we use to reference the object. We created an object and we called it user1. This is the object in the memory. So this object is allocated memory in the Java memory, and you can identify it with an address. This is the address of my object. This address also helps to match my objects with my variables in the memory. And this variable, because we know this is a variable because it can be called anything, it references the object with this address. So like I said, user1 points to the actual object in memory. So this user1 points to the object that it is defined for using the address. So this is an address in memory. It varies when you create different objects, different addresses are given, and no object can have the same address. And memory allocation depends on the number of variables defined in a class. So if I define 5 variables, the amount of memory I will be given will be different from when I define 3 variables. So this user matches the address, and I can use whatever I want from this object thanks to this user1, because the user1 is the variable that is declared for this object with this specific memory address. And I can assign data to my variable block as well. So I can assign my name John, gender male and age 25, and this will be stored in the memory. So when I need the user to call it, the user can call it using that address. So the new keyword helps to allocate objects, memory to object, and also returns what exactly is in that object, returns the memory to user 1 thanks to the memory address. And it also applies to objects of the same class with different memory addresses. So if I have user 1, like I've been mentioning earlier, with this memory address, it tells me that user 1 has a name of John, as a male gender, and is age 25. If I have another user with a different address, the variable is user 2, and it matches to this object with this address, which is Betty, female, and 30. And I have another user, Stacy, which has a different memory address, and it matches to Stacy, who is a female and is age 20. So for us to define, we'll go to the example now to see how it actually works. So from this place, we've defined our objects. We've used the new keyword, so our object exists in the Java memory. So we're going to assign values to our variables now. So we'll just say user1 dots, and as you can see the age, the gender, the name. If I say dot name equals John, and then I say user 1 dot age equal, needs to be an integer, 25. User 1 dot gender equals male. And then I can say user 1 should order food. If I run this, I should get John wants to order a 3-course meal. Format it. So it says John wants to order a 3-course meal. So what goes on here is an object is created. The object is allocated memory, and then I assigned some values to my variables. So I assigned John to name, 25 to age, and male to gender. So this is a method. When the compiler gets to this method, it looks for where this method has been defined. And because it is not in the main class, it checks other classes and sees that, it is in the class user. It comes into this class, sees that, it doesn't take in any parameter, and then it says, what does it say? What does the code actually say I should do? And it says name, which is John, wants to order a 3-course meal. And if I want to use my has siblings method, I can easily say user 1 dot has siblings, and let's say user 1 has 1 sibling. I can run it and see, and it says John has 1 sibling. 6 stars. John has 1 sibling. If I say John has 0, it says John has 0 sibling. 0 sibling. So it basically goes to the method that has it. When it's running, it comes down, passes the order food, and it comes to has siblings. Where is this has siblings in the application? It's in user. If number of siblings is greater than 1, then system.out John John has one sibling, John has more than one sibling, like 5 siblings or whatever siblings is put there. If number of siblings is equal to 1, then John has 1 sibling, else John has 0 siblings. And I just start because I made a mistake earlier. And it says John has 1 sibling. If I put 8, it should say John has 8 siblings. So we can write this in the main class as a result of an object created. And if I create another object called user2, to create an object, you need to first declare the object user2, or you can do it like this. You can say user2 equal new user. This is another way of writing the object. And then you declare the name user2.name equals Betty. User2.age equals 30, and user2.gender equals female. And you can do user2.update profile. And if we run this, we should see that name is Betty. Name is Betty, gender is female, and age is 30. So you see that name is Betty, gender is female, and age is 30. So this is just an example of how you can create an object in Java and call the methods. This user2 checks for the update profile method, which is in the user class, and then it comes and starts working its way down one at a time. So it goes down from this first system.out.println, and then this second one, and then this third one, and then it prints it out as required. And you can always create multiple objects. You can say user, new user. You can do different things with objects from a class. And because this class has a format, the object also follows that format. Because I cannot come and do user2.color. There is no color defined in the class. So the object is modeled from the class. The class contains the blueprint of what an object should have, and if it doesn't have it, you need to define it in a class before it can be used. So that's about it with object creation. We have constructors next. Constructors is a very important keyword in when you're defining your classes or using object-oriented programming. So from our previous example that we just discussed, we can see that we have an object called user1, and it creates the new keyword allocates memory to our user1 for the object. So this user, you can see is different from this user, even though it's the same, it's from the same class because of this parenthesis at the end. This is a default constructor that is provided by Java. So we didn't really have to define what we want our constructor to look like. What are constructors? Constructors are not methods, but they are a code block in our Java class that is used to construct objects. So how you want your object to look like, that is what will be put in your constructors. It's also used to initialize variables in your class. So it has some rules. It should be the same name as the class. As you can see, this class is called user, and this constructor is also called user. It needs to be the same name as the class. It doesn't have a return type, and when it's not compulsory to declare constructors because Java creates a default constructor for you. But if you want your objects to have a certain format, you should declare constructors for them. And once you've declared a constructor, there is no default constructor that Java uses. It uses the one that you've already declared. Constructors cannot be inherited, abstract, static, or final. So we've talked about the static, where we said that it is bound to the class and not the object or the instance of a class. And we'll talk about inheritance and abstraction and final in the coming lectures. So these are some of the rules that constructors have to follow. So same name as class, has no return type, declaring constructors is not mandatory, then no default constructors if one has already been declared, and constructors cannot be inherited, abstract, static, or final. We've got two types of constructors. The no argument constructors, which it doesn't take in any parameter, and we've got the one that takes in parameter. So the default one that has been used by Java doesn't take in any parameter. That's why you can use it easily like that and just define it straight up. But if you want your constructor to do something, then you need to put parameters with it, or you can just make it default. So any object that is created, there will be default variables for it, and I'll give an example of that now. So back to our user class, just below when we've defined the variables, we are going to define a default constructor. So a constructor that doesn't take in any parameter. And we need the public keyword, needs to be the same name as the class. Our class is user, doesn't take in any parameter, and I want it to say out the println, this is a default constructor. So if I define my class new user, this is the constructor that I've created here because it doesn't take in any parameter, and if I run it, I should get null values for all of these. Let me run it, and I should only get what the constructor says. This is the default constructor. So I'm going to remove put them in comments for now. If I run it, it says this is the default constructor. And when I ask it to give me the profile, it says no because I have not defined any variables, and the constructor I have defined just says this is a default constructor. So we're going to create a constructor that takes in parameters, public, then user, same name as class, let's not forget that, and it takes in parameters of string, name, string, gender, and integer, age. So usually when you create a constructor, the number of parameters is always equal to the number of variables that have been defined in your class. So if you've got 3 variables, you can define 3 parameters or 2 or 1, depending on how you want your object to look like, or what you want your object to do, or what you need your object to do. So for us, we would now assign our variables, our class variables, to the parameters that we've created. And to do this, since they are the same name and we want to be able to differentiate them, we're going to use the keyword called this. So this keyword just tells the compiler that I am referring to the variables that I have defined in the class, not these variables in my constructor, I want the variables in my class. So this dot name is equal to name. This dot gender is equal to gender, and this dot age is equal to age. And this is a constructor that takes in 3 parameters. And to call that constructor, we're going to create our user, new user, equal new user. And we want it to take in parameters. So we're just going to declare our parameters straight up. So John, male, and 21. So you can see that we've already assigned values to our variables in just a line, instead of getting it with dot age, dot gender, dot name. We can get it straight up from here. And then we can just say new user dot update profile. And if we run this, we should get name is John, gender is male, and age is 21. So this is how constructors are used in Java. They're useful for creating object and initializing variables, and also helping to encapsulate your variables, so to keep your variables within the class, so it's secure and safe from anything that could happen in your application. So there are differences between constructors and methods. They are not the same thing, even though they look alike. First of all, constructors have no return type. As you've seen earlier, we just defined our constructors with just 2 keywords, which is the public and the user, which is the same name as the class. It can take in parameters if you want it to, but the major thing is that it doesn't have a return type. In methods, you see that return type is either void or a data type or an object, but in this case, it doesn't have a return type. So it is the same name as the class. It is not going to be a constructor if it's not the same name as the class. And methods obviously doesn't have the same name as class. They are doing words that you need it to do something. And Java has a default constructor. If you don't have a constructor in your class, Java will create one for you and make you use one. And Java does not have a default method. So that is all for constructors. It's basically used for constructing objects in Java, how you want your objects to look like in your code, and you can play around with it and make different objects with different parameters and different types. So we're going to move on to getters and setters. Getters and setters are they're called methods. So it's the get method and the set method. So usually in a code, you wouldn't want to make all your variables public because of data security and just different things that can happen. Because if your variables are public, that means anyone can access it, any class can access it, and this makes your variable vulnerable, and it can be easily used by anyone, and this can really affect your projects or your application. It's something that if it's data that is very sensitive that you're dealing with. So to avoid this, we're going to make our variables private, and we're going to access them using methods that are called getters and setters. So it helps you get your variables and it helps you set your variables. So your variables doesn't leave your class, it stays in your class and it stays safe. So this is an example here. My variable name, I'm going to change it to private. So private means restricted access, so no one can access it except my class. And I'm going to create a getter, which will return a string, which is what I need my name to be. I need my name to be a string, and then we'll return name, return this name. And then I'm going to create another method called setName, which will take in a new name and will assign that new name to my name that I have declared in my class. So we're going to create getters and setters for my class called user. So I'm going to go over to my class, change my name from public to private because I don't want people to access it anyhow. And then I'm going to create my getters and setters under my constructor. So they're going to be public get name, or sorry, public void, public string. Sorry, one thing is that your set methods help to set your variable value, so they don't return anything, they just set it for you. So the return type is void, and your get method returns your variable value. So it returns the data type of your variable value that you set in your class. So like now, this is my getter. It returns a string because what I have set is a string, and my setter is void, so it doesn't return anything. It just assigns a value to my variable. So this is get name, and then I want it to return this name, so return this name. And then I have public void set name, and it's going to take in a string called new name, and it's going to assign my name to my name in my class to the new name. And then I'm going to do it for gender and age. So I'm just going to copy and paste to save time. And I'm going to set it. I'm going to change this to gender. Then change this to gender. Then change this to gender again. New gender. Gender. New gender. And then I'm going to do the same for my age, but this is going to be an integer because it's returning an integer, because the integer is an integer that was defined. So get age, return age, integer, set age, new age, this is an integer. So these are my setters and getters that we use to access my variables. And when I go to my main class, instead of defining my names here, I can just leave this as this one, the default constructor, and delete this one. I can say new user dot set name. So instead of just putting user dot name, I am encapsulating, I'm keeping, storing, safeguarding my variable in my class. So I'm just accessing it using set name. So I'm going to set my name to John. New user dot set my gender to male, a new user dot set my age to 25. And if I run this and I say new user dot update profile, I should get the exact same thing. His name is John, gender is male, age is 25. One useful thing that you should take notes when using setters and getters is that if I go down to my update profile and I want to change my name, I can just say set age equals to this dot age, and then I can change my age to I can just change my age from here. So this set sorry guys. And then it says new age is age. So if I go here and then I set my age again, new user dot set age. Sorry, from here you put get age. I set my age to 26. I said my birthday and I turned 26 already. I say new user dot update profile, and I don't need to put this here. If I run this, you can see the age is 25, but I changed the value of the new user to 26, and it says new age is 26. So it basically allows for you to set your values and also change your values as required. So setters and getters are really useful when creating classes and objects, because it helps to encapsulate your variables and ensure they are not out there to the public for the world to see. So we're going to go into a practical example. This is a class diagram that is going to help us create our classes. So we need two classes. We need the user class and we need a car class. So a user can have many cars and a car can be owned by one user because of the registration number. So for the user class, we have four variables. We have a name, gender, age, and we also have the car, which is a car class, as a variable. And we have these two constructors and all these methods. For the car as well, we have 3 variables and we have all these methods. So we have 4 variables, 2 constructors, 8 getters and setters, other methods, and the same thing for the car. So we're going to create a car class because we already have our user class. And for the car class, I've already created the car class. So we'll just declare the variables private reg number, model, and color. String registration number, private string model, private string color. Then we'll create our getters and setters for this class. So IntelliJ helps us to create getters and setters without writing them. So you can just go right click on your keypad or your mouse and click on generate, and it says you can generate getters and setters, and you can generate it for the 3 variables, and it creates your getters and setters for you automatically. So that's our getters and setters created. We also have our constructors. So public car, I want an empty one, and then I want public car this reg number equals to this reg number. So we've got our 2 constructors. We also need a toString method. So this is a method that can be created thanks to Java. So we right click, we click on generate, and we click on toString. So it creates a toString method. It basically allows your method, your variables to be in a string. So instead of you writing system.out.println all the time, you can just use a toString method that helps to put your variables in a string. So now we've created our car class. We are going to put the car class. Apologies guys, this is our car class. It has 3 variables, 2 constructors, the getters and setters for each of the variables. So get reg number, set reg number, get module, set module, get color, set color. And then it also has a toString, which puts our variables in a string instead of us writing system.out.println all the time. And then we have our user, and in the class diagram we can see that car is a variable in our class user. So we're going to come up here, and then we're going to say private car. So declaring car as a variable makes it have all these properties in the car class. So we're going to create getters and setters for our car as well to get and set the cars that will be created. So we'll generate getters and setters for our car. Click on OK, and you can see that it gets and the car has been created. I'm going to change this to, I'm going to update this and put system.out. I'm going to create a new method called display. I change this to display profile. Include this to get name, get gender, and get age. And then I'm going to say system and car is plus get car. So if I go to my main class and I change this to display, I'm going to create a new user 2 equals to new user, and I set my name to Betty. user2.set age to 20, user2.set set gender to female. And because car is an object of this class car, we need to also initialize the object and set values for that object. So I'm going to say car equals new car. I'm going to define the registration number ABCXY12 The model is an Honda Civic. And it has a pastel blue color. So I can use my user2 to set car and then put in this variable of this object that I've called, because my set car in the user class requires needs a parameter of a car. So an object needs an object parameter, which is this object I've created. So I'm going to put it in here, car. And then I'm going to say user2 dot display profile. And if I run this, you can see that it says name is Betty, gender is female, age is 20, and our car has a registration number of ABCXY123. It's an Honda Civic model and it has a pastel blue color. So we do not necessarily have to declare any method here. We just use this car class to create an object in the user class, which shows that the user is associated with the car class. This user class is associated with the car class because an object of the user class can have an object of the car class. So Betty has a car, which is an Honda Civic, and has a registration number of this and that color. So classes can be used inside each other, with each other, and can be called in the main class or can be called in each other. So I can also check Betty has a sibling. We've done that before. So if I say user2 dot has siblings 7, doesn't affect the new car declaration that has happened. Says Betty has 7 siblings. So this is just a basic idea of how classes and objects and constructors and getters and setters and method work in object-oriented programming in Java. And that is the end of the class. I'm going to go to the chat to see if anyone has any questions. Does anyone have any questions? That is me done with the class for today. So if you have any other questions, we can answer them in 11 minutes. Thank you, Vice 10. Please explain the override section. What section are you talking about? Does anyone have any questions? Oh. In the car class, this override is basically a method that has been called, it's a method that has been created by Java. So there's a method called toString, but because I need to use it, I am overriding what has been written there and I'm putting my own there. So it's a keyword that will be discussed later on, but it's just basically me overriding what has been written in that method and writing my own there. So let me see if I can go into the method. So if I go into this toString method, it doesn't allow me go in. Okay. Doesn't really allow me go in, but I should be able to. It just basically means I overrode the method that was written by Java earlier. Okay, so this is the toString method, and I am overriding it in my car. It's a keyword that will be discussed later on next week. Please, can you explain the difference between functions and methods on one and a variable and properties? Functions are basic, methods are functions, but it's just that methods are bound to a class. You cannot write functions in Java without a class. In other programming languages, you can just write the functions without it being bound to a class or being tied to a class. But in Java, you need to define your functions in a class, which makes it methods. They are basically the same thing, but it's just that methods are functions bound to a class, and variables are what your objects possess. So like the data your object possess. So for example, these three here are your variables, and yeah, they're just characteristics of what your class or what your object possess. So this is a class called car, and it has a registration number, it has a model, it has a color. It's just data that your car possesses that you need to write in your application. The lectures will be available as soon as possible and will be posted on the Telegram group chat. Okay, I understand, Ben. Thank you for that. Does anyone else have any questions?